In this lesson, we're going to look at solving for an unknown angle measure or an unknown side length using the sine law. Now, you can see the sine law written right here, and I've written it in two different formats. You can see that in one, I have written the sine A, sine B, and sine C, that is the sine of the angle measure on top, and then the little a, b, c, which are the side lengths on the bottom. Well, it can also be written in this format here with the side lengths on top and the angles on the bottom. And why would you want to use it in either format? Well, typically it's very easy if you write the unknown value that you're searching for, either the side length or the angle, on top, because it makes it very easy to isolate that variable with one step. And I'll show you this when we go through these two little examples. Okay, so first things first. In the first triangle, we notice that we have an angle measure of 82 degrees, and we do not have a 90-degree right angle triangle here. If we did have a right angle triangle, we would use SOHCAHTOA and the primary trig ratios to help us solve for an angle measure or side length, but we don't, so we're going to go ahead and attempt to use the sine law on this triangle. Okay, this is not an ambiguous case situation. Here we're trying to solve angle C, and the reason why it isn't an ambiguous case is that we are given all three side lengths, and that means that this triangle is locked in. It is set. There is no possible way for us to choose a different side length and therefore draw two different triangles. So here we go. We have one solution for this one. Let's go ahead and see if we can solve for angle C. The first thing I'm going to do is I'm going to label the side lengths. So opposite angle C is side little c. Opposite angle A is side little a. And opposite angle B is side little b. Now what we're looking for in order to use the sine law is we're looking for one complete pair. So I need a complete angle and its associated measure. And I can see that I have that right here. And then the side that I'm solving for, which is side C, or angle C, I need to ensure that I have the side length opposite that, and I do. So here's the other pair that we're going to use in our calculation. So the two that I'm going to be using are sides A and angle A, and side C and angle C. So I'm just going to use two of them. Now I'm searching for an angle, so I'm going to use this version of the sine law right here, the one with the angles on top. So I'm going to write the sine of this unknown angle C over side length C, which is 20, will be equal to the sine of my known angle, angle A, which has an angle measure of 82 degrees, and that will be divided by its side length, which is 29. Now, by writing the unknown value for the angle C up top, you can see that with one step, I can then move the 20 to the other side, and it'll move with multiplication to be 20 sine 82 over 29. And now I've got sine C isolated. Okay, now we want just the angle measure of C, not sine C. So to get the angle measure of C, I'm going to move sine to the other side, which will cause it to become the inverse sine of 20 times sine 82, all of that over 29. All right, so entering these values into the calculator, we're going to say second function sine, and there's our inverse sine, 20 times sine of 82 divided by 29. And that gives us a value of 43.074. So C is equal to 43.074. We weren't given direction as far as rounding to a specific number of decimal places, so I'll assume that they want us to round to the nearest degree, given that the other degrees in the triangle are whole numbers. So I'm going to suggest that the angle measure of angle C is 43 degrees. Okay, let's take a look at the example 2. Here we're asked to find the side length of BC, and BC is obviously in between the two vertices B and C. As a first step, we'll label the sides, little a, little b, and little c, to make sure that we're sure which angle is associated with which side. So 93 degrees, the side opposite that will be little a. 16, that side length, well, that's opposite angle B here, so that will be little b. And then this side down at the bottom is opposite angle 58, which is angle C, so there's little c. Now, in order to use the sine law to solve for the unknown side BC, we're going to need at least one complete pair. That is, the angle measure and its associated side. Well, so far we have a little bit of a problem here because I don't know angle B yet, and I know the side length, and I know angle C, but I don't know little c, which is the side length between A and B. So I can't use the sine law yet, but with a little bit of calculation here, I can come up with this angle B right in here. And it's quite simply just going to be 180, and we're going to subtract 58 for angle C. We're going to subtract 93 for angle A, and that leaves us with a degree measure of 29 degrees. So I know that this angle here is 29. And as soon as I do that, that opens up the sine law to us, because now we have a complete pair right there where we know the angle measure and its associated side length. And then the side that we're interested in, that is the side we're trying to solve, well, there's the A angle measure associated with the unknown side length A. Okay, so those are the two pairs we're going to use. Now, which one are we going to use to solve this? Well, we're going to use this version of the sine law. And we're going to do this one because we're solving for an unknown side length. So I'm going to write A up top. And that is going to be over the sine of 93 degrees. And that is going to equal the other pair. So B, side length of 16, over its angle, which is 29 degrees. Well, why is it useful writing it like that? Well, I think you can see that with one step, moving this sine 93 to the other side with multiplication, we can quickly come up with the value for A because we have been able to isolate A in one step. Okay, so really quick when you organize your sine law this way, writing the unknown value first right up on top of the fraction. So opening up a calculator and entering these values, we can solve for A. It's going to be 16 times the sine measure of 93 degrees divided by sine of 29 degrees, and that equals 32.957. So 32.957. If we were asked to round to perhaps one decimal place or the whole measure or whatever it is, we could then do some rounding. So why don't we round to one decimal place? Here, 0.95 would actually round up, and we would be left with 33.0, because that 5 would round the 9 to a 10. Okay, so there you have two examples using the sine law. The first, finding an unknown measure of an angle, and the next, finding an unknown length of a side. And you can write the sine law two different ways. You might have to do a little bit of work first to find an unknown angle just with simple subtraction. But once you get a complete pair, side length and angle measure, the sine law is open to you and you can go ahead and solve pretty easily in just one step.